Hey guys, what's up? Eddie Yahoo here with KissAnalog.com and IMARS 3-in-1 test instrument, oscilloscope, multimeter, and signal generator. I'd probably call it a multimeter with oscilloscope with signal generator functions. What do you think? Like, sure. Guys, we're going to continue testing this, and then we're going to open it up. And if you didn't see the first video, I showed some stuff, I did some testing, and yeah, so you might want to watch part one of this one, okay? Let's jump into this so we can make this video a little bit shorter. Oh, and I want to give 2 thumbs up to IMARS for sending this out to me for free. That was very nice of them. And also my YouTube members and my Patriots. Thanks, guys. And, you know, you can become a member for as little as $1 a month. You can hit the super like button. But you can support the channel for free, just like in the video. Okay? It helps a lot. Let's jump back in. Alright, guys. So I removed these little plugs from the leads. And you can see there's a kind of cross cut. So there's 4 nice pieces that can expand into your connection. And they're also angled away like this, so they fit nicely in the instrument, kind of leaning away. See how they lean, kind of point away instead of pointing straight down? So it just gives a more relaxed way for the leads to leave. And you can see how they've got some nice flex here. So I've seen this brand before. They're nice test leads. And then the tips are protected. They're not those kind where it's cut away. You could probably nip these off if you wanted to so you could expose the tips. But these are just to protect the tips because they are very sharp. But the ones that leave the exposed tips at the end are for Cat 3 and Cat 4, where it provides some extra insulation. In this case, we don't need that. These are Cat 2 meters. So there we go. And you can see it has a little ring right here, so except, you know, kind of click on it. They're not threaded. They just have these, okay? And they have this, you know, shroud to keep you from slipping up. And these kind of a soft, you know, texture here. The red is hard plastic, so pretty typical. You've probably seen these kind. Now this end's kind of stiff. It doesn't have much flex, so that's not great. But anyway, they're pretty typical. They're about 1 meter long. All right, let's start off with continuity. So we'll go to ohms, and we're ohms, and there's a little speaker right there above my thumb. So we hit F3 for that. So it highlights that, and here we go. I mean, this is very responsive, I think. And look at that, gives you the value. It's kind of high ohms. Oh, there we go. I got these little grooves where they're stuck in. See if it goes, okay, 0.2. Okay, so there you go. And I think you could hear that buzzing sound. Pretty loud. Okay, guys, you've probably, if you watch my videos, you've probably seen this stack of reference resistors. So I'm going to take the 10 ohm off the stack first. Okay, typical spacing for things such as like these kind of connectors, if you put a BNC cable with grabbers on the end. So it's nice to have meters that are spaced so they'll accept this. So let's see if it does. I imagine it's going to, no problem. If I can get my hands in there. Can I push down? There we go. And here we go. So now I'm going to put the rest of them in there, and you can just kind of look at the ohms. So 9.9. Now that's a 10 ohm resistor. If I let it sit there for a moment, it goes from 10 to 9.9. Okay, so yeah, that's within tolerance, but not dead on, because these resistors are pretty close to dead on. Now this one here is 100 ohm. Okay, and if you look at the tolerance, it's 0.025% plus minus. Okay, there's 100 ohm plugged in there, and I'm going to put the 10 ohm on top just for fun. Okay, so in parallel, it's 9 ohms. All right. So, yeah. Okay, so that was dead on, 100 ohms. Oh, now it's 99.9. Yeah, sometimes I find you have to wait just a couple moments for some meters to kind of really settle in. They kind of go back and forth. So that's pretty darn close to 100 ohms, right? I mean, it's within tolerance of the meter. Okay, now we have the 10K. All right, that one's dead on. Well, then I wait a moment, then it kind of goes back and forth. So if anything, it's measuring just barely on the lower end of the tolerance of these resistors. Okay, and now we're back to the 100K. All right, again, just that 99.9 or 99.8, just barely on the low side. Okay, guys, now I do have this 6 megohm resistor, okay? It's a big old boy. And there we are. Again, just a little bit on the lower side, but within tolerance. So resistance tolerance is 1% plus 5 digits. So that means this digit back here can go up and down 5 digits, okay? All right, guys, let's go to diode. So we got to go to this guy right here. That's diode. Now, here's a big old transistor, and the base is in the middle. So it's like 2 diodes, okay, from base to emitter or base to collector. So we put the positive on the base, and we touch that, and look at that. Whoops, I slid off. 0.523 on the one, and on the other one, 0.538. So that's the emitter, and the first was collector. And if you notice, there's no beep. So a lot of meters today don't do the beeps anymore. All right, guys, we're going to do a capacitor, this big old 10 millifarad. So let's go to capacitor. Okay, so plus lead on this end. We got the negative one on this guy. Okay, so here, let's touch. Okay, it's kind of hard to do on the camera, sorry. See how long it takes. These big caps take a little time to charge them up. Oh, that's pretty fast. Okay, they generally read down the lower 9 millifarads, 9,000 microfarad. So that looks like a pretty good reading. All right, there's a 0.47 microfarad. Okay, I'll hold that one, and then we'll touch that lead. And 0.47. Wow. Nice. All right, this is a 68 nanofarad. I'm holding one lead on a pin there, and look at that. There we go. So, yeah, nice. All right, guys, in diode mode, I like to check the voltage with the DC voltmeter. So this, my KPS, that's a super nice meter. It's set up to read voltage, and let's see what. Okay, so this guy puts out about 3.26 if we round it up. So yeah, that is, you know, it's interesting. I just noticed the 3 volts here. So it'll light up a lot of diodes and LEDs. Now, it's a diode checker. It's funny how many people just automatically go to LEDs, but it's a diode checker, and knowing the voltage, you know that you can light up just, you know, most LEDs. All right, next test, I'm going to use this Uni-T power supply. This is a big, nice linear power supply, and it has these memories. So 2 volts, 10, 3.3, 32, and 5. We're going to check to see how fast the meter captures these and what it looks like as it goes through the ranges. All right, guys, I'm going to turn on the power supply. Okay, I'm going to set for the highest voltage so you can see how it goes through the range real quick. Whoops, we got to go to voltage, right? So let's go to volts. And it defaults to DC, which is nice to know that. And then we have AC, volts, hertz, and duty. Okay, so here we go. Oh, okay. I think it beeped at us and gave us a high voltage thing because we're over 30 volts. So nice. And I think this says it's in the 60 volt range. So that's pretty cool that it tells us the range too. Okay, let's go next one. Okay, 5 volts, and look, we're in the 6 volt range. So that's why we get all these digits. 3. Okay, so we stayed in the 6 volt range, so that's why it was so quick. Okay, 60 volt range, and we're 9.98. Okay. And we went back to the 2 volt. So yeah, you can see, okay, I'm going to just kind of jump from 2 to, okay. Yeah, that's what it's doing, is it's flashing and telling us the voltage. And, you know, and also remember, it tells you what terminals you're supposed to be plugged into, which we are, obviously. So, okay. I just wanted to, it's kind of nice to see how fast it changes ranges. And, you know, some meters, like say a Fluke, as it changes range, you'll see OL for just a flash before it goes to the next range, where this one's a little quicker, right? Okay, we'll go from 2 to 32, and then from 32 back down to 2. All right, so I just wanted to show you that. Now we're going to go 32 and then off. So kind of cool, right? All right, guys, I'm plugged into my AC power supply up there by iTech. Very nice AC power supply. And we're coming down here, we're looking at voltage. So there's 124 volts, and look, it's giving me the voltage sign. So let's go down to 40 volts and see what happens. All right, still over. Let's go to 30. Okay, we're going to go to 25. Now, I'm kind of wondering if when we're in AC, if it always does that. Let's go to 10. Okay, it went away. So, all right. Well, that's interesting, right? So my power supply, by the way, says 9.6, and that's what we're reading here. So I punched in 10, but if there's no load, sometimes I don't know. It's kind of interesting how it does that. But okay, so let's look at the hertz. 21 hertz. Wait, hold up. What the heck? 21 kilohertz? See, should be 60. So I'm curious if 20 volts is enough to give frequency. Let's go up to 30. Okay, let's go back to volts. 28.92. My power supply says 28.9 as well. Okay, I'm going to go to 35. And we're still getting 18 kilohertz. That's crazy. Okay, let's go to 60 volts. Wow. That is nuts. Okay, I'm going to go 120 volts. Okay, I don't know if that's because I have a noisy connection with my leads. I just kind of plugged the leads into the socket up there, so I'm kind of wondering if that's what's going on or what, because that should be 60 hertz. Isn't that nuts? All right, so if I plugged into a wall plug, I mean, this is connected to my power strip, I get 59.98, which is what I expect. Duty cycle, close to 50, yeah. Okay, frequency, that was interesting. I'm going to try that power supply again. Okay, guys, now that I installed the power cord into the actual thing, and then I measured it this way, just like I did off the wall, now I'm getting 59.99. Okay, so you know what? I think it was just because I had a bad or intermittent connection and it was causing some noise. So good way to troubleshoot things. If you're getting a high frequency on 60 hertz, maybe there's a connection issue. Okay, guys, so let's measure some current. So I'm in the 2 plugs, just where it tells me to, and I'm coming off a generator right up there. So come from that generator there. Let's see what we see. All right, guys, so my generator is set for 100 millivolts, which puts out 0.65 milliamps. Okay, that's pretty cool, right? All right, so let's go up to 1 volt. So there's 6.77 milliamps. So it goes down really low in the milliamps. Now this is 1 kilohertz, right? Let's go to 5 kilohertz. Okay, so we're rolling off. So it's only going up to 1 kilohertz with accuracy. There's 1 kilohertz again. Okay, let's go to 100 hertz. Very little change. So up to 1 kilohertz looks good for reading AC current, okay? All right, guys, I have a DC current, and it's flowing through both meters. Have this really nice KPS meter just to show you the accuracy of this guy. It looks really good. Now, the way I'm doing that is I'm coming out of this power supply, turning it on. Right now it says 30, but I believe the accuracy of the meter is over this right now, okay? So at the low levels, my power supply might not be super accurate, but it comes into this multimeter, out of it, into this one, and out of it, and back to the power supply. Okay, so I just want to show you that setup. Now let's go ahead, and I'm going to lower the current on this guy. And we're going to just go down and see how low we can get accuracy. So now I'm at 10. Okay, now see, now I'm at 10 milliamps, which this one says 1.6, and this guy's registry now. So once we hit about 1 milliamp of current going through them, then they pop up. Okay, I'll stop once in a while just so we can let the meters catch up. And you can also see the speed and which one captures it. The other one, takes a moment longer. I'd say they're both pretty fast, right? Kind of move the dial kind of quickly. Okay, so we went out of range on this guy. So what is the range for milliamps? Oh, it probably tells me on the meter it's 400 milliamps. So see, we're getting close to 400 milliamps. So I'm going to switch it over to amps. All right, so now we're all the way over here. So now the accuracy of this guy is kind of, oh, you know what? That's AC. So let me go back to DC. Okay, there we go. So the accuracy looks really good. Okay. Okay, now we've gone over on this guy. So it was probably good for 600 milliamps. 500 says on the meter. So we're going to the 10 amp scale. All right. Now, I probably need to go over here to DC current, right? Now, the thing is the measurements change when you change from milliamp scale because there's an internal resistor in the meter. The voltage is dropped across it, and they call that the burden resistance. So there's a certain amount of burden resistance for the current to flow through so the meter can read voltage across that. Ohm's law, right? Current through resistance is voltage. So, okay, anyway, rounding that up, I mean, they look pretty darn close, right? And they're catching up to my power supply is starting to catch up to them. It's saying 800 milliamps. Okay, now my power supply says 900. So I think low current, my power supply just wasn't as accurate. Okay, yeah, I say 1 amp on my power supply. 1.1. Yeah, it looks pretty good, huh? 1.5. Okay. 2.0. Now, again, I trust this meter over everything. But I I think they're looking really good. So I'm going to go up to a little higher current just to see. Okay, my power supply says 6.2, and these guys are pretty much dead on agreeing with each other. So, yeah, this guy's doing a good job. Now, just as a note, when I take the probes out of both of them, this guy's screaming at me because when you're in current mode, that's when you can blow out fuses when you touch voltage. So this guy's saying, don't do it, don't do it. This one's just giving me that warning signal. It's like, plug in here, don't plug in, you know, you're reading current. So, but if I went to read voltage, oh, it's on hold mode too. Let's turn that off. All right, guys, something else I want to show you. This right here is a hold, okay? So if I come up here and I'm like, okay, here's my voltages. I'm going to hit that hold button. And then I get a hold right here, okay? See that? Okay, now watch. Now, if I change the voltage, it changes the voltage, but it holds the voltage here. So if I change it again, so if I hit hold, maybe you're charging something, you hit hold, you want to see what the voltage is, and then as it creeps up, you can watch this to see where you started and where you're going to. I don't know. You know, so that's kind of a neat feature, though. All right, guys, took the battery compartment off. We have a little insert here, machine head screw, and the lid. So it's funny, the batteries are kind of hot glued to there, so I'll just kind of leave them on there. But yeah, there we go, two 18650s, and compartment looks nice. Yeah, I mean, what can I say? So, you know, let's open it up, take a look. All right, guys, so these are the kind of screws that came out there. And I'll tell you what, man, they were in there tight. So almost I was afraid they were Loctited. And then we have these rubber bumpers that fit on the side. And they just kind of fit down into a groove along here. And yeah, they're not really easy to get off, actually. Okay, so hopefully that's all this I have to do. Yeah, I feel it coming apart now. Kind of hard to do with one hand. I like to do, okay, like to let you guys see it at the same time I see it. This plastic's actually pretty thick and durable. It looks like, wow. Okay, what do we see here? See a ribbon cable and a buzzer. Okay, we have a PTC right here. Now remember, this is class or category 2. So we don't have a lot of the protection MOVs you'd think you'd normally see because we're not in that kind of environment where we're going to see arcs. Looks like there's another board down there. Looks like 2 boards. Okay, so the way the inputs come in, the scope inputs, they look nice. We have 2 cans for EMI protection. Keep the shielding. And some chips. Wow, a lot of chips. Looks like an optocoupler right here. And a little power supply right here. Another little optocoupler looks like right there. And then it looks like we have little surface mount fuses, okay? And a resistor for current sensing instead of a shunt. I mean, you know, I think that's a nice touch. You get some accuracy. I think if these guys blew, you could put a through-hole fuse across these terminals here, so you wouldn't even have to replace those if you didn't want to. If they blew out, you just unsolder them, knock them off the board, and solder a through hole in there. So you have options. All right, guys, kind of like to have you see things with me now. I had to take screws out of these 4 corners here, okay, and then this little plastic thing that felt, you know, that kept things in place up here, and this came loose, and then I kind of tugged. And I feel like right there, there's probably a board-to-board connector. But it's loose now, so I'm going to carefully open it up. All right, that's cool, because see, there is a flex cable there. I'm going to lay it on the other half, the thing there. Now, wow, look at this big shield here. Wow. That is interesting. So this looks like it's running the display, right? And looks like we have a power supply right here. And there's our USB-C. So yeah, the power comes in. We got some regulation going on there. And then look at these chips. Pretty interesting. A lot of processors. There's a crystal. And the way the terminals are put down looks nice and neat, nice and clean. That's interesting. They show you where that surface mount resistor, if you replace it with the regular resistor, it'd go across there. I think that's what that's saying. All right, guys, it looks like they've taken off the chip information off this chip. And this one's got a big marker across it, so it's kind of hard to see what it says. I mean, I could see it if I wanted to, but, you know, I don't need to pick apart their circuit. There are big ground planes here, and you can see right here these tabs. That's where the cans on the other side are grounded to this side. So, yeah, it's pretty interesting. Now, it turns out there's just a single pin right here that must have been connected in here. That when I pulled it apart, I felt some resistance. I thought there'd be a whole row of pins plugged into here, and I'm assuming it's plugged into here. It could be into one of these holes maybe. So, oh yeah, there's another one right here. So there's one here, one here. So that could be here and here. And so that could be grounding. So they could be trying to ground this to this. Interesting. I mean, that's 2 big circuit boards. That's not really cheap. And it's interesting they cut out the board here so these caps could protrude so they could get the boards nice and close. So these chips, by the way, they've got ground planes on this board, but over here they've got this big old shield, which also helps shield the stuff on this side. Okay, guys, right here, there's a marking on the board. It's kind of interesting. It says ET202D _ OSC. And then below it is E1, like ONE, 240111. So that must be the rev or whatever of this board. All right, guys, so what do you think? I think the build construction looks good. I was impressed that the 2 circuit boards, that looks expensive. All the metal boxes for shielding. I mean, it looks like they went out of their way to make as good an instrument as they can, which, you know, in the old days, some of these, you know, Chinese products, it seemed like they were trying to save every dime or every penny they could, right? In this case, this seems pretty impressive. But I think the not giving the 2 probes, the 2 scope probes, that was a misstep, I think. I think they should have done that. You know, moving the thing around, I think if they changed the GUI a little bit so we didn't have to go through the menu to change these arrows from moving the trace up and down and back and forth to changing the time base and the voltage, the amplitude, it'd be nice to just have function keys for that. So I think those are the negative things on this. But what do you guys think? The price wise, use the link down below. I think it gives you a discount. Is it 15%? Not sure. Check it down below. It could be different from the time you see this video. I'll try to keep it updated, okay? But this is fairly new for IMARS, I believe. So the price on Amazon, it is not a sale price, but with the link down below, I think it'll come out to, I don't know, $85, $90, I'm thinking. I'm not sure. But the probes it comes with, the little bag you put it in, it would be nice to have more of the Pyweets type cases, you know, these soft, flexible, or soft hard cases, I call them sometimes, versus the bag. I think the bag and the lack of the second probe kind of shows cutting corners, where when I open it up and look at it, it doesn't show that. So, you know what I mean? It gives kind of the wrong look, I think. What do you guys think? Leave your comments down below. Free way to support channels: like the video, share it, subscribe if you haven't done so. Really like to grow the channel. And what do you think of the shirt? Bought a few shirts for the channel. One of the things I do, spend money. I can't wear the same shirts all the time, right? So I had to buy a few more. Alright guys, thanks for watching. Let me know if you like the part 2, the really in-depth thing. Since it's kind of 3 meters, it just took a while to go through all those things. What do you think of that? I could go a lot quicker and just not going as depth or this longer format. It'd be nice to know what you guys think. All right? Hey, thanks for watching. We'll see you next time.